So this is a much easier question. Show that 4 square root 2 minus 1 over 3 plus square root 8 can be written in the form a square root 2 plus b, where a and b are integers to be found. Um, so first thing we can do is just write this out, right? So 4 squared minus 1 over 3 plus square root 8. And let's see if there's anything we can simplify. So first thing we can simplify, I would say, is definitely this 8 square root 8. So what is square root 8? Basically, it's square root 4 times square root 2, right? Square root 4 is just 2. So 2 times square root 2 gives us 2 square root 2. So let's input this back into our equation. So 4 square root 2 minus 1 over 3 plus 2 square root 2. Now what we want to do is multiply by the conjugate of the denominator, because we want to get rid of the radical in the denominator, right? So conjugate is 3 minus 2 square root 2. Then we just multiply 3 minus 2 square root 2 on the numerator and denominator. And if we take this over here, we had 4 square root 2 minus 1, 3 minus 2 square root 2. And for this we can just use FOIL, first outside, inside last. So go like this, first, outside, inside last. This is just the order we like multiply the terms by. So first, 4 times 3 is 12. 4 times negative 2 square root 2 is negative 8 square root 2. Square root 2 times 3 is just 3 square root 2. And square root 2 times negative 2 square root 2 is just negative 2 square root 4. Now, how can we like combine like terms and simplify this? So first, we notice that these both have the same thing inside the square root, so we can add them. 12 minus 8 square root 2 plus 3 square root 2, so that gives us minus 5 square root 2 minus 2 square root 4. But actually, this can be simplified right now. So negative 2 square root 4. Square root 4 is just 2. So it's just negative 2 times 2 equals negative 4. So this will just become negative 4. And then 12 minus 4 is 8. So this would become 8 minus 5 square root 2. But this is not our final answer because we still have the denominator 2 times by, which should be easy because it's just a difference of squares. So this is our numerator so far, and if we do the denominator, it's just a difference of squares, so it's 3 plus square root 2 times 3 minus 2 square root 2. Say that's our a and b because there's this is a binomial, right? So we know that from the perfect squares formula, a minus b, a plus b, it should give us always a squared minus b squared. In this case, this is our a, this is our b, so it should be 3 squared minus 2 square root 2 squared gives us 9 minus 4 times 2. 9 minus 8 equals 1. This is our denominator. And what we can do now is just put these into the fraction. And way we do that is basically, yeah, it's just gonna be 8 minus 5 square root 2 over 1, which just gives us 8 minus 5 square root 2 as our final answer. So actually, yeah, this was our final answer, but we still have, in a real problem, we always have to do the denominator too, but our final answer can be written in the form a squared 2 plus b, where a and b are integers to be found. So if we just rearrange this, a squared 2, so it was negative 5 square root 2 plus 8. So in this case, a is negative 5, b is 8, positive 8, and that's our answer. So that's how to rationalize very easy when you have square root in the denominator and you want to find a and b as integers to be found. So that's final answer. So a is negative 5, b is 8, and that's how you rationalize. So yeah, that's all.